Welcome to Study Loop.
Hi everyone, thanks for joining me today. What we have is a problem dealing with power and kinematics. We have a truck that has a mass of 15,000 kilograms and can deliver 50 kilowatts of power to its drive wheels. What we're asked to solve for is the delta x traveled and the time duration for when the velocity goes from 36 kilometers per hour to 54 kilometers per hour, and then 54 kilometers per hour to 72 kilometers per hour. So what we're going to do first is solve for the delta t. So we know that power is equal to force times velocity, and force can also be written as mass times acceleration times velocity. Now we can actually write acceleration as dv dt, so let's go ahead and do that. So mv dv dt is equal to power, and we can actually bring this v inside the differential and say that m dv squared over dt is equal to power. What I'm going to do now is bring the dt over to this side, and we have the equation that m dv squared is equal to p dt. Now let's integrate both sides, and what we get is 1/2 m vf squared minus vi squared is going to be equal to power times time. Just going to go ahead and write the limits in here, v initial and vf. So let's actually go ahead and solve for time. So we put parentheses around this too. Let's go ahead and solve for time. So we see that time is going to be equal to m over 2 times the power times vf squared minus v initial squared. Now this is good for us because we know the mass, we know the power, we know the final velocities we're looking at, and the initial velocities we're looking at. So plugging in all these known quantities, for the situation where we're looking at from 36 kilometers per hour to 54 kilometers per hour, we see that the delta t is 18.75 seconds. And the situation where it's going from 54 kilometers per hour to 72 kilometers per hour, the delta t is 26.25 seconds. So that's part one of our problem. We also are looking for the delta x that is traveled, and this is where we can just use kinematics. We can say that the acceleration is equal to the final velocity minus the initial velocity over t, because we're dealing with problems that have constant acceleration. The total distance traveled during the time that we are concerned with is going to be s, and that is equal to the initial velocity during the time period plus 1/2 the acceleration times squared. Now, it's easy to see that we actually know all the quantities that we require to solve for s, right? We know acceleration because we know the final velocity and initial velocity because they're given to us. We solved for the delta t's right here, so those are simple and those can be plugged in as well. And after doing the plug and chug, we see that for case 1, when we're going from 36 kilometers per hour to 54 kilometers per hour, the delta x is equal to 234.38 meters. And the situation where we're going from 54 kilometers per hour to 72 kilometers per hour, the delta x is 459.38 meters. And that is our final answer.